Hi, welcome to another 4AC work example. Here we want to look at the August 2014 examination paper, question 1. Now question 1 reads as follows. A supply voltage ET with a sinusoidal waveform given is connected to a circuit comprising of a resistor, an inductor, and a capacitor in series. Now we are asked to calculate the frequency of the supply waveform, the period of the waveform, and also the RMS value of ET. Part B wants us to determine the voltage input waveform as a phasor, and also to calculate the total impedance in polar form as well as the power factor. That means I want to look at this whole circuit and determine what's the total impedance and also calculate the power factor. Next, we want to sketch and label the impedance diagram. Part C wants us to determine the incoming supply current in phasor form as well as in sinusoidal form. Part D wants us to determine the voltages VRT, VLT, and VCT in phasor form. And Part E wants us to calculate the values of the inductor here, and the capacitor, right, given the reactance. Part F wants us to draw the waveform of ET, the input voltage, and the IT, the incoming current, on the same axis, indicating the peak values, the period, and the phase difference. Well, let's start. We have to answer this question. What I'll normally do is to write down all the information that is given. In this case, the input voltage, their sinusoidal waveform, and a very quick sketch of what are the components, the resistor, the inductor, and the capacitor. Alright, now for part A, I can derive from this waveform the angular velocity is equal to 314 radians per second. Alright, but omega is also equals to 2 pi the frequency. So based on this, I can reorganize this formula to calculate the frequency. Right, so F is omega over 2 pi, so it's 314 over 2 pi. That gives me about 50 Hertz, which is the frequency we use in Singapore AC supply. Then the period of this waveform, from here to here, T, is then given as the 1 second divided by the frequency. So that's 1 upon 50, and gives me 0.02, or I could just write it 20 milliseconds. And finally, the RMS value of this waveform is given as the peak value divided by √2. So the peak value from this waveform is 325 divided by √2. Right? So I can leave it this way, or I can calculate it and get 229.81 volt. That's the RMS value. In Singapore, we always say 230 AC. That's what we mean by RMS. Alright, so that's the answer for part A.